question. All right, so we had multiple levels of product ownership. Not being co-located was not an easy thing, especially from that perspective. So we had the senior software development managers who reported to me were actually subject matter experts. At the same time, we have at SITA what we call business consultants as well. So that's a role. They are subject matter experts, basically. They are people who are hired from the airlines. So they're actually people who did the job of booking, of checking in people, etc. Right? So they were at the airport or in the back office. Those people worked very, very, very closely as part of the cross-functional team. So product ownership was actually the role of one team, not one person. In addition to this, now you have the product manager. And the product manager was not in the cross-functional team. The product manager is the person, one person, who defines the direction of the product, and therefore the roadmap. And the software development managers, as well as the SMEs or the business consultants, worked from that roadmap and defined the requirements and had a set of architects to define the design artifacts. So this is, in a sense, the product owner in an agile way. But it's not one person. As I said, we did things very unusual, in the unusual way. Because it's not the fact of one person very often. It's multiple people. Now, at the core team level, at the offshore core team, we had one proxy product owner. And for each and every Scrum team, we had 50% BA. So the BA, proxy product owner, was shared between two teams.
Who certified the demo?
So then the demos on the 15th and last day of the month are done by the offshore partner, by the Scrum teams themselves, in fact, back to the cross-functional team. And the cross-functional team, as the product owner, accepts the demo, makes comments, decides on changes, and that's how we had that rework, of course, because some of the GUI, some of the logic had to be changed, that's the requirements, or some of the design artifacts had to be changed at the service level, for instance. Does that make sense? Yeah. So it's not a traditional, it's not one person, not for that scale.
So we have the presentation here.
I'm audible? Yep. Sorry for the delay. It was a format problem. Like if my voice is a bit harsh, because this weather got to me. So if there's anything unclear or ambiguous, just let me know. I'll repeat it. So the topic for the talk today is called this delivery, like the cleaner, faster, and the better way to do it. Before we start with the actual content, let's just have a look at why we are here. When we get the client's requirement, he has a beautiful picture in his mind with all the beautiful features, good design, UI, or a very peppy thing, which can be delivered and will get sold in one day. While developing, the developer's notion on localhost is kind of like a rough idea of exactly what client told him. But if not followed with proper practices, the kind of final delivery that goes is like this, which will be kind of a total shift from what client asked to. This can happen if you go with the big bang product releases, or even with the shorter term releases, but with not following the practice very well. So we'll just have a look at how to do that. The topic for the day, continuous delivery. Cleaner as in no more messy deployment schemes. Faster as in no more operation handoffs. One of the key values behind DevOps feature as well. and no more feedback delays, as in the features that were being pushed, if there is an issue with them, like getting the feedback back to the developers, interaction between the developers and the ops folks. Better, as in the deployment, the releases being more predictable, more responsive, more business deliverable, the control, what's going in the release being more in the control of business. So, like, because this conference is mainly around DevOps, so like CD and DevOps, they kind of tied together. DevOps is more of a culture and practices shift from the traditional way, which is a means to an end to what continuous delivery actually holds in its mindset as goal. I'm Abhishek. I've been in DevOps. I've been doing DevOps practice for ThoughtWorks for like last 2.5 years or so. So, I divided this presentation in mainly 3 parts. The pipeline has the part 1. I'm mainly covering the concepts, which are like very they're base concepts, but they're required to understand the bigger picture. Part 2 will have mainly the practical approaches, the tooling, the different stages that will be required from CD's point of view and with an application of DevOps practices in it. And part 3 will actually have 1 or 2 case studies, which depending on time how much is left. We'll see. I'll try to keep it short and like wrap up on time. Maybe we're late. So, like all the buzzwords in the industry, like continuous one. Today itself we have heard about continuous build, continuous integration, continuous deployment, continuous delivery. There's continuous design, then like even though integration part, then like promiscuous integration and different terms. So like let's understand before moving forward what all these different buzzwords actually mean. So continuous integration, it's as the term itself says, it's all about integration. Integration between the requirement posed to the developer and like the code he sends. The integration between the developer giving out the feature and the QA folks, the quality analysis folks. Integration between each and every single Git commit, each and every code commit that your developer makes or your QA makes, and its effect in the release cycle. So, like the major chunks of values behind it that need to be followed. First one, test-driven development. Like there has been what to say. Yeah. So there are lots of different views for and against delivery, how to do it, when to do it, and when not to do it as well. So, what the TDD's test-driven development is all about is its trust. Trust around the feature that you're trying to release. Trust around the more additional feature, the more additional capability you are adding to someone else's release, someone else's added code base already there. The trust between QAs and your developers, the trust between each and every member of a team that, okay, if person X even in remote location has done some work on a particular piece of feature, and he's not in like the team anymore, has moved on to some other team or to some other project. The work done is still trusted because of the sets that surround it, the credibility of those tests if they're written properly. The second is smaller feature releases. So, like we have mainly 2 terms in like the way we work. One is mainly stories. So each and every feature that we work on, the smaller things that we try to add on to our application, we can turn them as stories. They have a user, they have one particular feature that it wants to, and like some acceptance criteria around it. And then there's another term called epic. So epic is kind of so like let's take an analogy. So if you're trying to deliver say a mail app, so you will have a feature to send mails. Now sending mails is a very generic kind of feature. It has sending text mails, sending HTML mails, editing of inserting images, formatting the text, and all sorts of things. So, like all those smaller things that I just mentioned, those approaching them one by one is much more safer, is much more trusted, and is much more testable, cleanly testable, and hence much more cleanly deliverable. Third one is automated build propagation. So it's mainly like if we are doing continuous integration, you'll have one pipeline, say for each and every single component of a project that you have. So there are a few APIs. There is a main web app that uses those APIs and some other components that are there. There is smoke test pipeline, which where they kind of integrate the base set of integration test kind of run. Then there's an end-to-end pipeline where like all the details tests which can be which comes to a QA's mind to maintain the credibility of the releases are there. So like the build propagation from one stage to other, from other to another further, that need to be like a bit more automated. If like after each and every stage a user need to go and click, then like there's actually what to say, you are not utilizing your continuous integration pipeline fully. For faster feedback. So why actually all this was done? So like in a bigger project or in a smaller project, when like the multiple developers are working there, the multiple QAs trying to test that. For each and every commit that you make, if the quicker you get the feedback that okay, it's working, it's compatible with all the other stuff that's already in my app, it's being tested. So at the unit test level, it's passing. So I push the commit. Like my QAs write the integration test, and so it's passing at that. So at whatever level it's failing, the faster you get the issue, the more quickly you can resolve it, and actually utilize the continuous integration pipeline. Continuous deployment. So continuous deployment is kind of multiple stages. Like it's when you it's the ultimate stage of trust actually on your product. So you have a continuous integration pipeline where at the end you get a release build, which can then be utilized on your production, pushed onto your production, and get like you can get an enable there. So in continuous deployment, what happens is like is actually like a talking where in initial there are a few integration points, full integration points where okay, there are lots of people working together, collaborating, and after like it's in the range where it can be a bit can be handed over. Automatically it gets deployed. It will get deployed to your production, and then like suggested that you have a post-deployment test as well, which will like cover the base set if it need to be rolled back or not, and so like each and every git commit that you do, which passes your all the stages of your unit tests, integration tests, acceptance tests, and performance tests, and they'll get to the deployment without any manual intervention. Continuous delivery, it's kind of a step back from that. So in continuous deployment, any commit reaching your production stage is automated after the build gets generated, like it gets pushed to your production and will further ahead. The automated pushing it to production, that part actually it's in the hands of business. So that's the main difference between the continuous delivery and the continuous deployment practice. So yeah, that was the main concept around that. Part 2 is mainly around the tooling. So mainly we'll be discussing around the source code management, the task management, CI pipeline, and the further we'll take a look at one by one. So source code management, in particular to In particular, to your continuous delivery practices, anyway, you need a source code management, code management system where each and every developer who is working on the system can collaborate their own work and they can use it further. So there are two. There is actually one main argument there, which was there some time back, when some of the industry experts, they said that okay, our feature branches are not that good of an idea for a continuous, when you are are not that good of an idea, because moving ahead, when the project will grow, merging back from feature branches to main line, depending on your stage, it won't happen always, but there is always a probability that there will be a bigger chunk and you will get lost in the merge conflict. So, keep trying pushing your code mainly to the to the main line always, and follow that path. Then there were a few discussions on that, and the main suggested approach was the feature toggle bit, where what you do is each and every feature that you work, there's a toggle to actually turn it off or on. So by that, there are mainly two problems that you get. One is it's kind of feature branching by abstraction. You turn it off for your production until you know that it's okay, it's stable and it's ready to be exposed in your production. And second, when a particular feature needs to go in production, that decision kind of goes into your client's hand. And mainly the suggested ways, all these feature toggles, they get their turn off, turn on values from environment variables or certain configuration, which can be managed by automated configuration management systems. And hence, the only thing that your client needs to do is turn off a value up, on or off, and get a feature in. I'm sorry. Yeah, get a feature in the production. Task management. Task management is in whatever task. So normally in developer world, what we do is for each and every story, there'll be a card. There'll be multiple stages, as in ready for dev, in dev, in pro, in test, ready for test, in test, and ready to deploy. So similarly, when DevOps practice, we started adopting DevOps practices, what we did was we kind of adopted the same model for all the systems side tasks as well, and started involving our clients into that, so that they had a better idea on all the aspects of the product that we were building upon. And it also brought in the visibility, the clear picture of things like what cycle time particular kind of tasks what we're taking, how if we needed an improvement or particular performing a task or certain things. Continuous integration pipelines. Obviously, when you're talking about continuous delivery, we need a CI tool where we can set our pipelines. Pipelines as in, so for those folks who don't know, CI tool will be there, Jenkins, Go, Travis, CI. The way you set your pipelines, that matters a lot. So normally, what people tend to do is, a common mistake that has been seen is, there are lots of tasks which can be actually queued into parallel, also get into sequential bits. So that actually makes your pipeline take much longer time than it actually should. So that's one of the key things to note when you are actually creating pipelines. And obviously, when you have the automatic progression of the build should be maintained from this. Then testing frameworks and levels. Around testing frameworks and levels, one thing that, as you already discussed, that the main thing that should do is like the level of trust that it brings. To make any change, to refactor any piece of code that's already there, or to improve upon things. So the kind of practice, so mainly from the discussion that I've heard in the community and like a personal there are mainly three scenes where like the approach kind of changes in which you apply TG. So there's a normal there's a normal set where you are like working on a greenfield project. It's a fresh start project. So the standard way, like you write this first, you work, you write the code that makes it pass, and goes there. The second one is like if suppose you're spiking on something because you're not sure that that particular piece of code is not currently a part of your system. You're not, you don't have that much time. You're not even sure if that will be included or not. So in that, what's suggested is once you're done spiking, then there are two processes that you can follow. One is like write the test and bring the bring the same working piece of code and then evolve it whenever you get back to it. The second piece is like write the test for it and then like rewrite the thing so the rewriting thing is actually suggested because that kind of tends to refine your model that you might not have done when you were spiking. And the third thing is like suppose if you have a legacy system involved which is kind of backing up your main app that you're working on. So in that case, suppose there's some other team, client team, which is working on the legacy system. So obviously you need to keep a check that whatever APIs you're using in the legacy system, if they change, like your system will start to break. So unless you yourself are working on the legacy system, or don't try to push in changes to like for that team to write test and all. Before that, start have a test around the API that you're using and start your work, and then like try to push in the better practices that if you think you need to adapt it. It need to be fast for sure because like suppose if you unit test takes more than 10-15 minutes. So suppose I'll write a code, I need to run a unit test before I push in that change. And it takes like around half an hour or so. Like most of the developers will start skipping those tests and pushing their changes that okay, it will turn up red on CI, so I'll know. So it needs to be fast. Actually one of the cases, what happened in one of the projects that we did was in our integration test. So over a period of time, like after certain months, it started taking around 1 hour or so, the integration test pipeline. So like it was a huge pain because for each and every commit, like everyone is supposed to wait for that, and if it turns red, then like okay, first go back to that, figure out what's wrong there, fix it, then like work ahead. So in such cases, what's suggested is figure out tests which doesn't cross each other, separate them out and run them parallelly. That actually we, like in our specific case, that brought down our test to like 15, the integration test to 15 minutes long. And then there are some other actually tools available in the market like a test load balancer. So the kind of capability that they have is so suppose your test X failed in your first run. So the next time what it will do is it won't like run from the start and at test X it will again fail. It will run test X first, so like it's still failing. It fails first and like it goes back and so the feedback time gets reduced. There's a right place for each required test. Actually, this particular thing is mainly for the DevOps related. This particular thing is for the DevOps related part. So normally what people start doing is initially when the chef and puppet unit testing tools got in the market. They were kind of adaptation from the RSpec, Ruby word RSpec test, which was so they were already they were testing things which are already tested. Those also so suppose your shell is saying install this package, there will be a test that okay install this package, but the installing of the that particular package install thing that's already tested at chef level. So the kind of test that that you need to do is kind of changes completely. Excuse me, how much time do I have? It's up. What? Okay. Start it.
Thank you, Abhishek.
Thank you, Abhishek. It was a wonderful, excellent PPT given presentation by Abhishek from ThoughtWorks. Again, coffee break for 30 minutes. So after that, again, we can come back to it.
Okay, thanks, Nitesh. First of all, thank you, Nitesh and UNICOM for this opportunity. Happy to be here. This is our space, so it's always. I don't see any, DevOps product vendors except for ThoughtWorks, of course.
IBM.
IBM. Oh, wonderful. Okay. Nice to have this. Is great. Always present. So the topic that is there, just to keep it punchy, I've said this, it's not going to be realizing business value. I'm going to talk about a few business use cases, case studies that we have worked with some of our customers, and I've tried to bucket them to kind of for our own use, and I thought I can share that as well for this audience. So what I'm going to do is just a quick introduction about CloudMunch. We are a DevOps platform vendor, not a consulting company. Just have one platform, built it over the past 2 years. Startup, running through the hoops, what we have done in the last few years, we've learned through the last 2 years, and we have acquired a few customers. And interestingly, a lot of them have fitting in different buckets. So I wanted to talk about how, from a consumer perspective, being a provider, how they're seeing DevOps and how probably it may be useful in this forum as well. Right? So that's really the topic. So the first one I'm going to talk is, and this is a classical DevOps case. So the way I've bucketed them is something like this. In the table at the bottom, right? So you typically have Dev. You have Ops. They're never together. Obviously, that's the phenomenon we want to bring, right? So what I've seen is in some of these are like various kinds of customers, right? So you have Dev in-house, Ops in-house, that's a very common pattern that you see. You see Dev given to a vendor, Ops held internally, and that's also a common pattern. You see Dev given to vendor and Ops given to a different vendor, which is again a common pattern. Pretty much, don't do development, but only Dev. You see Dev in-house, Ops to a vendor. That is also common pattern. See, I will talk about a few case studies in all these patterns. Obviously, there may be more. Dev crowdsourced, and that's something upcoming. You've seen these all app stores happening, so you have some case study on that. Dev is crowdsourced, but Ops is managed internally. And Dev is crowdsourced, and Ops is managed to a vendor. There are various patterns that we have seen. Obviously, you can have more kind of things. So I also put a line on who could be a potential buyer for me, but I'm happy to share. So whom do you track if this is in-house? It's the CTO who makes the decision in terms of, because he's doing the product, he's running the ops as well. So that's, so I think you can read through that. But the interesting thing is on the right corner, where business teams are buying DevOps as well, which is not seen, it's little unusual, is what I thought. I thought I was sharing. So in this context, right, this case study, where a couple of large customers we have in this space, will fall in these LO highlighted here. It's basically dev is in-house or through a vendor, but there is some